You buy a brand new pair of dress shoes, and within 3 or 4 months of walking to the office, the material is already creasing, peeling, and actively falling apart at the seams. Put that $30 mass-produced shoe next to a handmade $300 Oxford on a workbench, and they might look identical at a quick glance. But if we strip away the polish and break both of these shoes down to their base structural engineering, the differences become glaring. Replacing cheap shoes multiple times a year is an economic cycle designed by fast fashion. Escaping it requires looking exactly at what you are stepping on. This cross-section shows the complete anatomy of a leather hide. The deception starts at the retail shelf with a stamp that reads, "Genuine leather." It sounds authentic, but it is actually a specific industry term for the lowest, weakest layer of the hide, completely stripped of its natural strength. Moving up the cross-section, we find top-grain leather. To hide natural animal scars, factory machines sand away the outermost surface. That process removes the densest fibers, compromising the material's durability to create an artificially smooth finish. True premium shoemakers rely exclusively on full-grain calfskin. Here, the natural outermost layer remains entirely intact, retaining tight biological fibers that offer maximum flexibility, breathability, and resistance to tearing. Purchasing full-grain leather is a structural requirement for a shoe expected to survive years of concrete pavement and weather. That requirement begins with raw materials. Processing natural leather in traditional stone vats is the first of roughly 180 distinct manual operations. Artisans cut exclusively from the back or the butt of the hide. These specific biological zones have the tightest pores and the least amount of natural stretch, meaning the leather will resist heavy creasing as it breaks in. Mass-market factories cut heavily from the belly of the hide to maximize their yield. Belly leather is loose and highly elastic, which is why cheap shoes immediately form deep, permanent wrinkles across the toe box the first time you bend your foot. To lock in the anatomical shape, craftsmen perform a rigorous process called lasting. Using heavy metal pliers, they manually pull the full-grain upper over a solid foot mold, hammering in nails to physically anchor the tension. Combining dense, unyielding hide sections with forceful physical shaping guarantees the upper will eventually map perfectly to your foot without collapsing. Beneath that leather exterior lies a hidden chassis, engineered specifically for the human skeletal structure, built around these exact customized lasts. Cut open a $30 shoe, and you will find a flat sheet of hollow plastic covered by synthetic mesh. It traps body heat, breeds odor-causing bacteria, and offers zero physical support. In contrast, this X-ray diagram reveals a critical component hidden inside premium footwear, the steel shank. This rigid metal strip is embedded into the base, bridging the heel and ball. Watch how the shank reacts during a standard stride. Absorbing the physical load of your body weight, it holds the foot in a supported posture, preventing your arch from collapsing. Without that internal chassis, your muscles and lower back are forced to absorb the impact all day long, turning a budget shoe into a physiological liability. But the ultimate point of failure in any footwear lies at a single, vulnerable seam, the exact line where the bottom sole meets the upper. Fast fashion relies entirely on cemented construction. Robotic arms spray a layer of industrial glue, press the pieces together, and send them to retail. The moment street water or high summer heat penetrates that seam, the adhesive chemically breaks down, and the sole simply falls off. This diagram shows a centuries-old engineering solution called the Goodyear Welt. Instead of glue, a separate leather strip, the welt, runs around the perimeter. A needle aggressively double stitches this welt through the upper, insole, and outsole. This interlocking thread pattern creates an impenetrable mechanical barrier, sealing the internal cavity and repelling external moisture. That internal cavity is then filmed with a hot, natural cork paste. As you wear the shoe over weeks and months, that cork slowly compresses under your weight, forming a permanent, customized mold of your exact footprint. The Goodyear Welt is a complex mechanical isolation system. It builds a watertight vault around your foot, immune to the failures of chemical adhesives. Because the outsole is stitched exclusively to the independent welt, rather than directly to the delicate leather upper, the entire bottom of the shoe is modular. When the trad eventually wears thin, a cobbler can cleanly sever those bottom stitches. They detach the degraded outsole completely, without ever tearing or damaging the original leather body above it. Applying a fresh sole resets the clock. Notice how the heavily aged leather on these Oxfords has not deteriorated. It has developed a rich patina, ready to continue its life on a brand new foundation. Glued shoes are rendered garbage upon their first failure. A welted shoe is engineered specifically for infinite repairability. This structural engineering directly alters the long-term economics of your wardrobe when we calculate the true cost per wear over a decade. This chart compares replacing a $50 cemented shoe every 6 months against maintaining a single $300 welted shoe. As the timeline progresses, the disposable shoe's cost rapidly scales upward, vastly exceeding the flat upfront cost of the premium option. Those 180 manual operations represent generations of human labor. It is centuries of preserved craftsmanship actively resisting the modern tide of automated, disposable production. Purchasing a premium, handcrafted shoe is a decisive investment in enduring engineering and personal physical health. It is a complete rejection of fast fashion.